One of the first steps in actually conducting a study is to sample from the population you've defined. For illustrative purposes, our population is going to be 4,000 subjects, middle school students that were tested on the PACER test. That will be our population. Our first step is going to be to use SPSS to determine some parameters of this population so that we can have an idea what the population looks like. And we'll also take a look at the shape of the distribution. Here are the data on the population, the actual mean of the 4,000 students. Actually, there are only 3,943 because we had 57 students missing data on the PACER. The mean is 30.96, the median is 27, the mode is 20, standard deviation is 16.66. It looks to be skewed positively, and it is leptokurtic. Now we're going to obtain a random sample. We can use SPSS to do this. Here are the steps. Go to Data, select Cases, choose Random Sample of Cases button, choose the Sample button and insert 5 in the percent of all cases box, continue, select Copy Selected Cases to a New Dataset button and put Random in the dataset name box, click OK. This creates a new data view screen. Compute the relevant statistics for the sample. So here's the random sample and the statistics. Now let's compare these to the population values. Notice that most of the statistics are fairly close. The mean, standard deviation, median, mode. The only one that has some difference is kurtosis. Another way to sample data is called systematic sample. This is done by deciding how many sample subjects are desired. We'll say in this case 200. Divide that number into the population size, 4,000, to get 20. Select a random number from 1 to 20, let's say 10, and then starting with subject 10, select every 20th subject for inclusion in the sample. We did that here and then calculated the descriptive statistics again. Now we're going to put up all three, population, the random sample, and the systematic sample, and notice that they all again are very close. The means are close, the standard deviations are close, and the skewness and kurtosis are somewhat off, but not too bad. They look fairly similar. Another way to sample is called a stratified sample. Our data contains information about the age, ethnicity, and social economic status of our students. We could ensure that a sample would contain the same percentage of subjects with the various levels of these characteristics as there are in the population. For example, our population consists of 742 11-year-olds, which is 18.5% of the population, and 30% are 12-year-olds, and 39% are 13-year-olds, and 17% are 14-year-olds. To stratify a sample of 200 subjects on age, we would randomly select 37 of the 742 11-year-olds, 61 of the 12-year-olds,
78 of the 13-year-olds,
and 34 of the 14-year-olds. The next type of sampling is called the accidental sample. An accidental sample occurs when the investigator simply chooses the first some number of subjects available. For illustrative purposes here, what we did was select the first 200 cases of the 4,000. Unfortunately, much data relies on accidental samples because of the difficulty in securing random samples. Here are the descriptive statistics for the accidental sample and the accompanying histogram. Now we're going to compare the population values to the accidental sample, and you'll notice that they are quite different. The mean is quite off. The standard deviation and skewness and kurtosis are all quite different. Another term that's often used with accidental sampling is convenience sampling, because you just pick the most convenient people available. So this has been a summary of the various ways that you might sample and the efficiency with which each of these ways sample the population accurately.